Good afternoon, everyone. My name is Muaaz, and I'm a PhD candidate in the Department of Computer Science. And I will be talking about high-performance reductive strategies for big data from LC-MS proteomics. So we all love to eat proteins, not only because they taste delicious, but also because they provide structural support to our body. And that is not it. Proteins also control all the chemical reactions taking place in our bodies. Now, protein molecules are large chain-like molecules. They're made up of combinations of 20 basic type of amino acids. Now, the sequence of amino acids inside the protein chain determines what that protein is going to do, if it is going to cause a disease like cancer, or if it is going to cause a cure for a disease like cancer. That is why we classify them as good or bad, depending upon their sequence. Now, that is why it is important that we sequence them, all the proteins in our body. Now, that is not possible because it can take anywhere between hundreds or even thousands of years if we do them manually. What the scientific community does is it converts the proteins using the techniques of chemistry into a form of digital data. This data is processed by computer algorithms, and at the output, these algorithms give the sequences of the proteins at input. Now, the problem is that these algorithms are very slow, and this data is very large. So large that on the modern-day computers, it can take anywhere between a few weeks to months of computational time. And patients with cancers don't have that type of time available. So we could speed things up using supercomputers like Titan, but these are multi-million-dollar machines, and not all the hospitals and labs are able to afford them. So as a solution, what I did was I took a gamer's PC with a GPU or a graphics processing unit in it, and these GPUs are very common nowadays in Xboxes and PlayStations. What I did was that, the difference between a CPU and a GPU is that a CPU has typically between 2 to 4 cores. These cores are very high-performance cores and are very complex in design, while a GPU can have anywhere between 500 to 3,000 cores. But these cores are very simple in design and very low in speed. So what I did was I redesigned these computer algorithms so that they could exploit the power of 3,000 cores of GPU as well as the power of CPU cores. And as a result, for a pre-processing algorithm working on an average-sized data set, I was able to reduce compute time from 3 days to an astonishing 30 seconds. That is also on just a $700 GPU instead of a $10,000 machine. Now, the impact of my work is that one of my algorithms is being used by the Department of Energy scientists for studying the relationship between proteins and genes, and which is helping them pinpoint the causes of many fatal cancers. And if you are interested in this work, please contact me for more information. I'll be glad to discuss. Thank you very much.